Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, in this video, I would like to discuss moment distribution method, beam analysis with support settlement. Beam with support settlement. Okay, so let's say this is the beam. Okay, this is a continuous beam. So this beam is going to analyze using moment distribution method. So this is under moment distribution method. So we will analyze this continuous beam. So this continuous beam A, B, C, D. Okay, A, B, C, D. A is fixed, D is also fixed, B and C is internal. Okay, are internal support. So we have four joint. So this beam will be analyzed. Okay, by considering deflection or delta or support settlement. Okay, which is located at B. And this is, let's say, equal to 35 mm. So we need to analyze using moment distribution method, and always remember, using moment distribution method, okay, we will analyze and moments. So what is actually end moment? End moment is also called as internal moment. Internal moment. So how many internal moment? Depending on how many members in this beam. So this beam has six end moment because there are three members. Okay, there are three members. So this beam, if I, for example, okay, so I want to resolve this into element or into members, and I will also draw the joint. Okay, there are four joint and three elements. So let's start with draw the element or the members. Okay, 1, 2, and 3. So this represent members. Members AB. This is A, AB. This is AB, B, C, C and D. C and D. So all these are members. Okay, member AB is subjected to point load at the center. Point load at the center. Okay, it is like this. Point load at the center. And then member BC is subjected to UDL. Along the member. This is UDL along member BC. And CD has no load on top of it. Okay. Okay. So these three members, okay, these three members has in total 6 N. A and B for member AB. Okay, A and B for member AB. B and C for member BC. And C and D for member CD. C and D for member CD. Okay, so these are all members. So what about join? Okay, for join, okay, but before that, okay, by looking at this beam, beam, the free body diagram for one by one members, A, B, B, C, C, D. Okay, we when we resolve as element or as one by one members like this, okay, we need to assume that each end of the beam are fixed end. So that is why we can apply fixed end moment formula. Okay, so the moment for fixed end AB, okay, will be like this. The fixed end moment. Always remember that fixed end moment is behavior. Fixed end moment is behavior. For BC, the fixed end moment is like this. Okay, and CD has no fixed end moment. CD has no fixed end moment. Okay. Okay, it will be like this. Okay, so if this is 70, okay, this is 70, and 3.65, 7.3 is at the center. So we can calculate the value, okay, the moment here as it is the PL over 8. It is P is 70, L is 7.3 divided by 8. So we get 63.875. The fixed end moment for AB. Fixed end moment for AB, 63875. 63875. So it is equal to, okay, this one is 63875 for both. 63875. Okay, this is FEM due to loading. So I just draw this before move to table, because I want to actually explain what is actually occur behind the table. Always remember that the fixed end moment is the first member end moment in the table. Okay, and the moment that we distribute is join moment. Okay, join moment. So the next one is 30. W is 30. W is 30. Length is also 7.3. 7.3. So we use WL squared over 12. It is WL squared over 12. W is 30. W is 30, L squared times 7.3. L squared over 12. This is 133.225. 133, this is 133.225. 133.225. So these are actually the fixed end moment value that we put into the table under column FEM. Okay, FEM. There will be 4 values of FEM, and FEM for CD, DC will be equal to 0, because FEM we calculate whatever force that is subjected on member. Okay, on member. So this is about beam. Okay, this is about beam. Okay, this is about beam. Now I want to move to join. This is beam or members. Okay, members. Members is the right word. Members. So we have member AB, we have member BC, we have member CD. Okay, beside members, we have to understand also join. Okay, understand also join. So we have join. Okay, we have join A. Okay, we have join A. Okay, join A. Sorry, fixed. Join A is fixed. A is fixed. B is roller. C is roller. D is fixed. So this is A, B, C, and D. And by referring to the above diagram members, okay, always remember that the joint moment is always opposite with member and moment. Opposite with member and moment means that the joint moment at A equal to this one, the green one. Okay, so 63.875, it is positive, so for joint will be negative. Okay, and 133.225 negative, for joint will be positive. Okay, same goes to C. For BC, it is positive 133. For joint C, it is negative. That's all. Okay, because CD 0. Okay, so the value will be 63.875. Okay, this one, the total. Okay, it is 63.875 and 133.225 total. Okay, total is 133.225. Okay, minus with 63.875. 6935. So total is 6935. Okay, this one is negative. This one is negative. This one is negative 133.225. Okay, negative because of the sign. So this will be 0. Okay, this is the joint moment. This is the joint moment. Okay, this is actually what is happening in the table. And this is for joint. Okay, so let's start with let's look at this diagram first. Okay, all fixed, so we use 4EI over 7.3. Okay, 4EI. This is 4EI divided by 7.3 as well for the K value. And the last one is 4EI divided by 3.65. Okay, for the distribution factor, distribution factor will be 0 here. Distribution factor will be 0. Total distribution factor for B is equal to 1. Total distribution factor for C equal to 1. Okay, about the carryover factor, all will be 0.5. So carryover factor, this is 0.5, this is 0.5, 0.5, 0.5. Okay, all 0.5. Okay, so let's start with table. Okay, let's start with this. Okay, so we will create table, okay, to calculate member and moment easily, because the process is repetitive process and easy to implement in the computer in Excel. Okay, we start with list of members. Okay, there are three members, means 6N. AB and BA for member number 1, BC, BC and CB for member number 2, CD and DC, CD, DC for member number 3. Okay, for K value, okay, since in this example, EI is constant, and EI actually do not need to substitute EI into K, because EI will be cancelled whenever we calculate distribution factor. So don't waste your time to calculate EI, K, by putting EI value inside. No need to do that. Okay, remain as EI, because EI will be cancelled whenever we calculate distribution factor. Okay, so for member AB, it is 4 divided by 7.3. Okay, it is 4 divided by 7.3. Okay, before I start, I actually want to do this first, distribution factor, fixed end moment, and then fixed end moment, and then distribution, this will be distribution number 1. Okay, carry over, distribution number 2, carry over, distribution number 3, carry over, distribution number 4, carry over, distribution number 5, distribution number 5, carry over, distribution number 6. Normally 5 or 6 times will be enough. Okay, we will find 0.0 something. Okay, if not, then continue to another distribution, another cycle. Okay, and end moment. This is M from table A. Okay, this is example considering support settlement, and support settlement we will have two approaches. Okay, to analyze support settlement. Okay, now I will show how to analyze end moment using two tables. Means one table calculate FEM due to external loading, and another one table calculate FEM due to a settlement. Then we combine the end moment. Okay, so this is M from table 1, MA. This is end moment. Okay, so I want to set the okay, let me produce the table first. And then I want to set the decimal places. Okay, I will use up to 3 decimal places for this. Okay, so this will be the same as well, because the length for AB and BC is equal. Okay, and this one is 4 divided by 3.65. Okay, you can check back. 3.65. Okay, that is the correct one. Okay. Okay, so we always remember that K is for member. So one member, whether it is AB, BA, will have same value, because it is same member. Okay, so now move to distribution factor. Distribution factor for N fixed 0. Okay, we have both N fixed A and D. Okay, 0. And distribution factor Okay, to calculate distribution factor, we calculate by using formula. It is a simple formula. It is joint stiffness divided by not joint stiffness, member stiffness divide by joint stiffness. It is like this. Okay, this is member divide by total, divide by total, divide by total, total B. Okay, KBA plus this. So we get 0.5. 0.5. And the total dF for B must equal to 1. So it is 1 minus 0.5. Also can be done like this. Okay, so next is 0.548 divided by total. Divide by total 0.548 plus 1.096. It is 0.333, so the remaining will be 1 minus 0.333. It is equal to 0.667. Okay, fixed end moment. Okay, we have calculated just now fixed end moment here. Okay, fixed end moment. Fixed end moment, look at the members. Okay, look at the members. Okay, it is 63.875 negative. It is 63875 negative. It is negative 63.875. 63.875. And then for BC, it is 133.225. 133.225. It is 133.225. 133.225. One negative. It is one negative. Okay. Then the joint moment we don't put into the table. The joint moment, because now we will move to distribution number 1, and the moment that we distribute is joint moment. So joint moment, we will distribute joint moment. Okay, the moment under inside the circle. Okay, we will use the factor, distribution factor. Distribution factor. Okay, so for first one, it is actually positive 63.875, representing by this. Representing by this. It is positive 63.875 for MAB for the first step. But the distribution factor is 0. That is why we don't have anything, okay, to be put here. Okay, and then we move to joint B. Joint B consists of BA plus BC. So we total this, we get, okay, total this, we get 69.35 equal to this, 69.35. It is positive. It is positive. Okay, it is positive. Total, I have put negative outside to represent opposite condition of joint moment. Okay, so this one we have to times with distribution factor. Distribution factor. Okay, and then again times with factor. Okay, and then continue to joint C. Joint C is negative 133.225 as shown in this diagram. This is negative 133.225. So this negative 133.225, we use this to calculate end moment. Okay, we time with factor. So that is why it is negative. Okay, because of the direction shown. Okay, so it must be negative. This one plus this times, okay, it is negative. It is negative. Now we time with factor. The factor is 0.333. 0.333. Okay, I put dollar sign to log column DF. Okay, it is negative 44.408. So we do the same for next one. Times with factor 0.667. 0.667. So I put dollar sign here to log column BF. Okay. And there's no value to be distributed for DC. Then we continue with the next step, which is called as carryover. For carryover, we have to carry the value to opposite. Means that it must cross boundary. A between A and B must cross boundary. Between B and C must cross boundary. Between C, D must cross boundary. Okay, cross boundary. Okay, so all factors is 0.5 because of all fixed. All fixed. Internal assume fixed. Internal fixed. D and A fixed. So all factors are 0.5. So that is why this we will get like this. Divide by 2. Okay. Divide by 2. This one. Divide by 2. And last one. This. Divide by 2. Okay. So move to distribution, the next distribution factor means next cycle. We will repeat the process again. So when we repeat the process again, when I use Excel, I can actually copy and paste this, okay, in next column. So I copy this and I paste 1, paste 2, paste 3, paste 4, and paste 5. And then please remember that, okay, I will clear this because in the table, we must stop at distribution. We cannot stop at carryover. We must stop at distribution. Okay, so basically 5 times or 6 times, okay, will be enough. Okay, or whenever the moment reaches 0, or whenever there is no moment to distribute. If 6 times still have 0.1, 0.3, for example, then continue another time. Okay, now I will sum all this. Okay, start from the first moment in the table. Remember, the first member and moment in the table end moment. Okay, end moment. Fixed end moment, fixed end moment. So don't count together with the F. You have to start with fixed end moment in the table. So total is this. Okay, so one thing that everyone should know is, okay, this is actually M. Okay, I copy this, put down. Okay, so we have here 40, AB, MAB is negative 40, MBA, MBC. These two must be 0. these two, when we plus these two, must be 0. So when you get other than that, means that something wrong somewhere. Okay, something somewhere. You must get 0 because in the question just now, okay, this MB is equal to 0, representing by roller. And roller, there's no moment in roller. So when we combine the structure, combine the members, okay, it is actually roller at position B and there is no moment at roller. So we must get MBA plus MBC, which is equal to 0. So how to get this? It is actually come from MBA plus MBC equal to 0, or MBA equal to negative MBC. So that is why, okay, we get this at 1 positive, 1 negative. Okay, we must always get like this, unless the moment there is external moment or couple moment given at that particular joint stated that there is a moment value at joint. Okay, without that, the moment equal to 0, like this. So that is why we have to make sure that for BABC, okay, the value must be same but in opposite condition. Okay, same goes to CB and CD. CB and CD again. CB and CD as MC is 0 because C is roller. So how to get this? It is actually MCB plus MCD equal to 0. So that is why we get CBCD 1 positive, 1 negative. When we draw it separately, one by one members, okay, we assume as fixed. We assume as fixed because it has moment. That is why we can assume as fixed. But when we combine back, we get like this. We get original one. And MB0, MC0 is correct because that is the original. The original roller, we know that roller M is 0. Okay, so that's why we get like this. That's why we get like this. So this table I will copy and paste into the class notebook just now. Okay, so maybe I want to highlight some more here. Highlight this. Okay, so I copy this and I will paste, okay, here. Okay, so this is table number 1. Table number 1. Okay, now we want to move to table number 2. So table number 1 is due to external loading only. Table number 1. Okay, now we want to move to table number 2. Table number 2, okay, we need to consider this. Okay, delta at B is equal to 35 mm. So for this and to analyze this, we have to consider the behavior as well. Okay, we have to draw the free body diagram for joint B, A, B, C get affected. A, B, C get affected. C, D remain at same position. So the free body diagram representing representing delta B is equal to 35 is like this. It is triangular. Okay, it is triangular. Okay, so this is A, B, and C. This is delta 35 mm. Length 7.3 meter, 7.3 meter. Okay, always remember that original beam position is 0.5. This is original position. So why I put this? Because the easiest way to identify sign of FEM due to support settlement, okay, is by determining the angle from original position. Okay, from original beam position. Okay, this one, the angle is okay. Okay, let's draw. Okay, from original beam position for AB, it is clockwise. Okay, AB clockwise. What about BC? BC is counterclockwise. BC is counterclockwise. Counterclockwise. Okay, this is very important because when we have like this, for example, look at the ruler. Okay, when beam AB is in position of this ruler, okay, to counter back, because the fixed end moment must counter back. Okay, apply moment to counter back. So we will get like this. Okay, see the movement to the right, clockwise or anti-clockwise, to move back to straight position. Means that this one want to move back to this one. Move to this one. Move back to its original position. This is AB. This is A. So AB, we want to move back to straight position. We have to apply moment. Apply moment like this. Which is actually opposite with angle. This angle. Opposite. So what we can conclude is, okay, if the angle is known as this symbol, okay, the angle. So what we can conclude is when angle is negative, angle is positive, FEM opposite. This is for AB. With angle and FEM, always opposite condition. Opposite. Condition. So move to BC. Okay, what about BC? Okay, what about BC? BC, the beam is like this. The beam after support settlement is like this. So from this, to move back to straight position, what should we do? Okay, to move back to straight position, we will apply moment this direction and this direction. Okay, it means that okay, by looking back at this diagram, okay, the angle here, this angle, okay, the angle for BC is counterclockwise, so FEM will be opposite, clockwise. So we can say that angle is negative, FEM positive. This one is not. This one, okay, should be positive, negative, negative, positive, negative. That is the correct one. Positive, negative. This one, negative, positive. Okay, negative, positive. So I explain you about this because we will calculate FEM. Okay, FEM for AB will equal to FEM for BA. And the formula is 6EI delta over delta B over L squared, 7.3 squared. But we have to identify which one is positive, which one is negative. Another one. FEM B C FEM CB. This is equal to 6EI delta B over 7.3. So between these two, which is positive? Okay, so for AB, it is like this. So to be able to straight back, to move back to its original position, we apply moment like this. We apply moment like this. And the moment is negative. The moment is negative. So we put negative here. Okay, and for BC, it is like this. And for having this as the beam after settlement, to move back to straight position, we will apply moment like this. So the moment here is positive. The moment is positive. Moment is positive. So let's say EI is 100,000 kilonewton meter square. Okay, we will calculate new FEM. We will calculate new FEM. So I will put into the table. So we will have table number 2. So I will copy this and put here. Okay, so the difference is only at FEM. So I clear this. Okay, so FEM for AB, AB is negative. AB is negative. It is negative 6 times 100,000 times 35. 0.035 divide by 7.3 L squared. 7.3. Okay, same one. And another one will be the same because delta is equal, length also equal, but sign is not equal. So sign must be positive. Okay, this one is positive. Positive. Okay, it is positive. So we get both. Okay, we get both. So it is just like this. It is just like this. So we get, okay, this is B, table B, table B. So now, okay, this is all the value and moment considering support settlement. Considering support settlement. Okay, support settlement. Okay, so the total moment will be, let's get the total moment. Okay, so total, so this is MB. Of course, you have to do outside or different table, okay, or write one by one back. Okay, this is to skip the step, so I am calculating it straight away. Okay, so we have to find the total. It is the total value. So the answer, okay, total M. So the answer, okay, is green one. Green one. Okay, so we get this. So this will be the second table. This will be second table. Okay, this will be second table. Okay, and then last value will be this. Okay, so this will be the answer. Okay, so the final answer will be this. So this one will be the final and moment. Final and moment.